This video is presented to you by www.testprepadda.com. Dear students, in the last two sessions of heat and thermodynamics, I discussed linear expansion, I discussed area expansion, and I discussed volume expansion. And we derived relations like L2 is equal to L1 1 plus alpha delta T for linear expansion, and we derived relation A2 is equal to A1 1 plus beta delta T for area expansion, and we derive relation V2 is equal to V1 1 plus gamma delta T for volume expansion. Here L1 is the initial length, L2 is the final length, delta T is the change in the temperature, and alpha is the coefficient of linear expansion. Here A1 is the initial area, A2 is the final area, this delta T is the change in the temperature, beta is the coefficient of superficial expansion. Here V1 is the initial volume, V2 is the final volume, delta T is the change in the temperature, and gamma is the coefficient of volume expansion. Now we have to find relation between alpha, beta and gamma. This alpha that is coefficient of linear expansion is also written as alpha L. This beta that is coefficient of superficial expansion is also written as alpha A, and this gamma, which is the coefficient of volume expansion, is also written as alpha V. Dear students, in this session I am going to talk about the relation between alpha, beta and gamma. But before I start the discussion of relation, I would like to tell you about isotropic and anisotropic expansions. Dear students, isotropic expansion means uniform expansion. Uniform expansion in all directions. If we increase temperature, uniform expansion takes place in all directions. Here in anisotropic expansion, the expansion is direction dependent. Consider a solid cube. This is the length, this is the width, and this is the height. For a cube, length, width and height will be same. If I take the example of cuboid, then length, width and height will be different. Now for isotropic expansion, the expansions should take place uniform in all directions, and for that the coefficient of linear expansion for length, width and height should be same. So those cases where the coefficient of linear expansion same in all directions, that we call as isotropic expansion. That substances will show isotropic expansion. But if the coefficient of linear expansion for length is, let us say, alpha 1, for width it is alpha 2, for height it is alpha 3, means coefficients of linear expansions are different in different directions, That is why the expansion will not be uniform in all directions, and the expansion will be called as anisotropic expansion. And dear students, let me tell you that anisotropic expansion is mainly observed in crystals. So here, first I will talk about relation between alpha, beta and gamma for isotropic expansion, and then I will talk about relation between alpha, beta and gamma for anisotropic expansion. Relation between alpha, beta and gamma for isotropic expansion. Consider a cuboid. Since it is a cuboid, so length, width and height will be different. Although I can take a cube to simplify things, but it is better to take a more generalized shape. For cube, L will be equal to W will be equal to H. Here, let the coefficient of linear expansion as alpha. Since it is the case of isotropic expansion, this alpha will be same in all directions, means it will be same for length, width and height. Now if the temperature is increased from T to T plus, let us say delta T, then new length will become L dash, and new width will become, let us say, W dash, and this new height will become, let us say, H dash. Now with the help of relation between new length and the original length, I can write L dash is equal to L into 1 plus alpha delta T. I can write W dash is equal to W1 plus alpha delta T, and I can write H dash is equal to H into 1 plus alpha delta T. Now first I will try to relate this coefficient of superficial expansion with the coefficient of linear expansion, and for that I will find this area of this one surface. Now if I try to write initial area, let us say A, it will be L into W, length into width. Now if I try to write final area means after this increase in the temperature, let us say A dash, it will be L dash into W dash, that is the final length into final width. Now how these two areas are related with each other? I can say A dash is equal to A into 1 plus beta delta T, where beta is the coefficient of superficial expansion. Now if I substitute values, A dash will be written as L dash W dash is equal to, this A will be written as L into W into 1 plus beta delta T. Now L dash into W dash, from here we can get L into W and 1 plus alpha delta T, 1 plus alpha delta T, so it will be square. So it will be L into W into 1 plus alpha delta T square is equal to L into W into 1 plus beta delta T. Here LW will get cancelled. Now open this square. So 1 plus alpha delta T square is equal to 1 plus beta delta T, and this will be 1 plus alpha square delta T square plus 2 alpha delta T is equal to 1 plus beta delta T. Since alpha is small, alpha square will be much small, so this can be neglected, and this way, beta comes as 2 alpha. Very special relation. The coefficient of superficial expansion is double of the coefficient of linear expansion for isotropic expansion. This point is clear? Now we will try to find the relation between this coefficient of volume expansion and coefficient of linear expansion. Students, look at this cuboid again. Here if I ask you what will be initial volume, it will be L into W into H. And what will be final volume? Final volume, let us say V dash. It will be L dash into W dash into H dash. And we all know we can write V dash is equal to V into 1 plus gamma times delta T. Now if I substitute values, here, L dash, W dash, H dash as this and this here, then we get 1 plus alpha delta T cube is equal to 1 plus gamma delta T. Now if you open this, it will be 1 plus A plus B cube. We know A plus B cube is equal to A cube plus B cube plus 3A square B plus 3B square A. So it will be 1 into alpha delta T cube plus 3 alpha delta T square plus 3 alpha delta T is equal to 1 plus gamma delta T. Now 1 will get cancelled and alpha square and alpha cube can be neglected here because the value of alpha is very small. So this term and this term, these two terms can be neglected, and here delta T will get cancelled. At the end we get gamma is equal to 3 alpha. Another very important result, the coefficient of volume expansion is 3 times the coefficient of linear expansion. So I can write alpha is equal to beta by 2 and alpha is equal to gamma by 3. This is very interesting result. And if I find ratio alpha is to beta is to gamma, it will come 1 is to 2 is to 3. Dear students, please note that this relation or these relations are valid only for isotropic expansion. Now I will talk about relation between alpha, beta and gamma for anisotropic expansion. Again, consider a cuboid here. This is length L, this is width W, and this is height H. Now this is the case of anisotropic expansion. So coefficients of linear expansion will be different in different directions. Let for length coefficient of linear expansion as alpha 1. Let for width it is alpha 2. Let for height it is alpha 3. Now in this case, when temperature is increased from T to T plus delta T, then let us say length becomes L dash, width becomes W dash, and height becomes, let us say, H dash. So I can write now L dash is equal to L 1 plus alpha 1 delta T, and W dash is equal to W 1 plus alpha 2 delta T, and H dash is equal to H 1 plus alpha 3 delta T. Now first relation between this beta and alpha. For that, I will find the area. Let us say this surface. So, what is the initial area? Initial area A is L into W. What is the final area? Final area A dash will be L dash into W dash. If I multiply here, it will be L into W into 1 plus alpha 1 delta T into 1 plus alpha 2 delta T. Now, relate A dash is equal to A into 1 plus beta delta T. Now, if I substitute A dash here and A here, this LW will get cancelled, and at the end I can write 1 plus beta delta T is equal to 1 plus alpha 1 delta T into 1 plus alpha 2 delta T. Now if you open this, you will get 1 plus alpha 1 delta T plus alpha 2 delta T plus alpha 1 alpha 2 delta T square. Now here you can see two small terms are multiplied, alpha 1 into alpha 2. That is why this will be very small quantity and this can be neglected. And here this 1 will get cancelled, delta T will get cancelled. At the end you can write beta is equal to alpha 1 plus alpha 2. Very special relation. This is for what type of expansion? Anisotropic, where the coefficient of linear expansion is different in different directions. So beta is coming as alpha 1 plus alpha 2. Beta is the coefficient of superficial expansion. Now I will try to find the relation between this gamma and alpha. And for that I will find the volume. Initial volume will be what? L into W into H. And what will be the final volume? L dash into W dash into H dash. I will write initial volume of that cuboid as L into W into H. Let this as V, and then final volume as L dash into W dash into H dash, and let us say that as V dash. We know V dash is equal to V into 1 plus gamma delta T. Now substitute all the values. Here I will write L dash W dash H dash is equal to L W H into 1 plus gamma delta T. This L dash is L into 1 plus alpha 1 delta T. This W dash is equal to W into 1 plus alpha 2 delta T. And this H dash is H into 1 plus alpha 3 delta T. And that is equated with L into W into H into 1 plus gamma delta T. This will get cancelled here. Now if you open this, then those terms will be neglected, where we get like alpha 1 into alpha 2 or alpha 2 into alpha 3 or alpha 1 into alpha 3 or alpha 1 into alpha 2 into alpha 3. And if you solve, you will get gamma is equal to alpha 1 plus alpha 2 plus alpha 3. So this is the relation between coefficient of volume expansion and coefficients of linear expansion for anisotropic expansion. Students, this is all about relation between coefficient of linear expansion, coefficient of superficial expansion, and coefficient of volume expansion. In the next video session, I will talk about the effect of thermal expansion on density, or better I say, we will discuss variation of density with the temperature. Thank you. This video is presented to you by www.testprepadda.com. testprepadda.com provides free audiovisual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.